Hello, this video demonstrates main functionality of the tool ErrorPro, stochastic tool for error propagation analysis. In order to run this tool in MacOS or Linux system, you need to execute ErrorPro sh shell script from the main directory. After the execution, ErrorPro asks you to specify the name of the model, let's call it ABC. ErrorPro is based on a dual graph error propagation model. It is a mathematical framework that describes the properties of the system that have the most influence on data error propagation processes. The system is represented as a set of executable elements. Let's define element A, and we also specify that it is a starting element, that the process starts with execution of element A. After that, we define control flow between the elements. Control flow arcs are weighted with transition probabilities. Element B will be executed with probability 0.7 after element A, and element C with probability 0.3. Let's add more control flow, and let's close the loop in such way that A executes again after execution of C. Now we are adding data flow, data storages D1, D2 and D3, and we are connecting them with the elements. For example, after the execution of the element A, it writes some data into D1 and D3. In addition, we add an data called output that represents critical output of the system. We are interested how many errors we will have in this critical output. Now let's set up conditions of the elements. It is the internal behavior. By default, you can see that with probability 1, we have no errors in both outputs of element A. Let's change it. Let's say that with probability 0.9, everything will be okay during the execution of element A. But we add new update, and we specify that with probability 0.1, we will have errors in both outputs, in output D1 and in output D3 of element A. The sum of the probability is 1. Let's close this dialog. Now A is marked as a faulty element. Let's set up B. We set up B in a following way. If no error in input, no error in output. But if we have an error in input, with probability 0.9, it will propagate to the output. And with probability 0.1, the output D2 of element B will contain no error. Check, everything's fine. Let's set up element C in a similar way. Element C has two inputs, D2 and D3. And we are setting it as follows. If there is an error in D2 or error in D3, then with probability 0.8, we will have error in this output. And we add another update that we will have no error with probability 0.2. Setup is finished. Let's check the model. We see a message, a warning, that number of steps is not specified. System is closed, and ErrorPro needs to know how many loops we will do, or in this case we set up the number of steps. One step is execution of one element. It is saved. We will do 100 steps. Let's check the system. Everything's fine. And now let's mark the data which is interested for us, which we will compute mean number of errors on the marked data. We run the computation, and ErrorPro shows us that, for example, D1 has mean number of errors 3.737, and the most interesting for us is this output. It has 3.63 errors during these 100 steps. This was the demonstration of the basic functionality. Thanks for watching.